So we begin our discussion now. Today first we'll do some numericals. So okay, so far, and we'll be bidding bye-bye to what you call speed today. Speed ka last scene hai. After that, it won't be speed anymore. So in speed, in this class of class 9 or 9th grade, we study about average speed, and we'll do some numericals. And average speed formula is equal to total distance traveled, TDT, by total time taken. Okay, make sure in this problem the units are same. Okay, make sure the units, and always take care of units in physics. In SI system, speed is measured in meters per second. Try to write ms-1 following the international system. Even if you write m/s, it's nothing wrong. So let's take the first problem. Okay, pehle easy problems aayega, and then we'll get. So the first problem is all about a scooterist. So scooterist means something like this. Okay, there is a person who is riding a scooter. It says the scooterist covers a distance. Okay, I'll just write the salient points. It covers a distance of 3 kilometers. Okay, and the time taken by the scooterist is 5 minutes. Okay, it's 5 minutes. That's average speed. And if you want to know what is speed equal to, speed is always distance over time, S/T. Okay, this is formula 1 and formula 2. S stands for distance or displacement. For both we use in this chapter, it will be all in straight line. So S/T, and if it confuses you, you can write it as distance over time. Okay, these two formulas will take. The scooterist converse. Calculate. We are asked to calculate his speed calculate the speed in centimeters per second. On the second option, we need to calculate the speed in meters per second. And on the third option, we need to calculate in kilometer per hour. So this problem is going to test your conversion skill. It is going to test your conversion skill, right? Shall we start? Number 1. Okay, we are supposed to convert it in centimeters per second. So what is speed equal to? Speed is equal to distance over time. Okay. So how do we calculate distance over time? We want the distance to be in centimeters. 3 kilometers means 3 into 10 to the power 3 meters. And every meter is again 10 to the power 2. Then it becomes centimeter. How many of you understood? How many did not understand this part? This part. How did I convert this? We are given 3 kilometers, right? 3 kilometers. How much is 3 kilometers in meters? 3 into 10 to the power 3 meters. Did you understand this? Kilo means 10 to the power 3. Now this meters to centimeters, 1 meter is 100 centimeters. So it becomes 3 into 10 to the power 3. So many meters. Now this becomes centimeter. Have you understood? Right?
Yes.
If still confusing, 1 kilometer is 1,000 meters and 1 meter is 100 centimeters. Right? Over time, and they've asked us to find in seconds, they've given in minutes. So 5 into 60. Now see how to do these problems without, you don't have calculator and all. So this becomes 3 into 10 to the power 5. And you can write 5 into 60 is 6 into 10, right? So how much does this become? 3 2s are 6. So it becomes 10 to the power 5 divided by 5 2 is 10 and 10. So that's 10 square. So ultimately it becomes 10 to the power 5 minus 2, that's 10 to the power 3. Okay? So the speed is 1000 centimeter second minus 1. Did you understand it? You can do your way, but if you use the exponents, it becomes easier. Did you understand this calculation? Anyone who has not understood, raise your hand. Nothing to be ashamed of here, but don't suppress. 10 to the power 3 and 10 to the power 2 adds up to give you 10 to the power 5. 60 has been split and written as 6 into 10.
So won't it be 5,000?
Why will it be 5,000?
Because 5 into 60.
5 into 60. So I have kept the 5. On top, Neha, you still have a 3. So this 3 cancel out the 6 with a 2, right? 3,
oh, okay.
1 is 3 and 3, 2 is 6. Did you understand?
Yeah.
5 into 2 makes it 10 and you have another 10. So it becomes 10 square. So 10 to the power 5 minus 10 to the power 2. sorry, divided by 10 to the power 2, that's 10 to the power 5 minus 2, which is 3. Class 8, x to the power m into x to the power n is equal to x to the power m plus n, and x to the power m divided by x to the power n is equal to x to the power m minus n. You remember? Exponents. Fine. Clear. Can we move to the next one? Next one we can do from the first one itself, right? Half of the job is done. Next one we have to express in meters per second. So express it in, now you've got, what is the speed? The speed is 1000 centimeters per second. You have to express it in meters per second. So 1000 divided by 100. Straight away this becomes meters. And second remains as second. So how much is the speed now? 10 meters per second. Centimeters to meters, the value will become small because centimeters. Zoe, did you understand this? Centimeter to meter, this part? Okay. And the third part, we will use our beautiful, the formula that we have. We are asked to find speed in kilometer per hour. We know 1 kilometer per hour is equal to 5 by 18 meters per second. Now you have to do the reverse, right? So which means 1 meter per second should be equal to how much? 18 kilometer, 18 by 5 kilometer per hour. Yes or no? Just reverse it. So you have, your speed is how much? 10 meters per second. So it becomes 180 divided by 5 kilometer per hour, which is equal to 5, 3, 15, 330, 5, 6, 30, 36 kilometers per hour. Anyone who has not understood, please do not suppress it. Ask.
Sir, it doesn't matter if we do it in a different method, right?
Why will it matter, dear? It doesn't matter at all. Only thing, as you are growing senior, you should try to think, adopt a method which makes your calculation as simpler as possible. There is no issue. End of the day, what people will look in is your value is the unit. Okay, Sanvi? But if there is a shorter way to do, why were we taught the chapters of exponents and all? Because as I say in class 8, you are only taught tools. Those tools you should now start using in your career as you go advanced. Like for example, Sanvi, this conversion, okay, this particular conversion, which one? I'm talking about this. This we will be using a lot. It straight away converts kilometers per hour to meters per second. Done? All of you? Right? This is typical unit conversion problem. Let's go to the next problem now. Can I move to the next problem? Okay. And few basics you can't forget, like what is kilometer in terms of meter. I told you millicenti decigram, deca, hecta, kilo is the way we memorize the conversions. Okay, let's go to next question. The next question. Okay, the next question says, there is a train A. There is a train A and the train travels, okay. Don't see the workout initially, okay. If you see the workout, you will have prejudice in your mind. Try and understand. Getting the right answer is not the issue. Understanding the problem. See, sometimes what happens, if you look into the problem, you will solve one correct. Can you solve every problem correctly? That is what you should target. So the train, there is a train A and the train A covers a distance of 120 kilometers in 3 hours. Okay, this is the story. And there is another train, and this train is train B. It covers a distance of 180 kilometers in 4 hours. Out of these two, you need to tell me which is the faster train. Now, what determines you are fast or slow? Your speed. Your speed determines. So if you find the speed of train A and you call it out as SA, it should be distance traveled by A, right? The distance Don't substitute values straight away. Distance traveled by A over the time taken by A. Now substitute. What is the distance? 120 kilometers. What is the time taken? 3 hours. Okay, let's try and see. So this is 40 kilometer per hour is the speed of this train. Speed of the train B. Okay, speed. I mean, I'm writing it as S here. You can write V also, just you need to mention. Okay. Anyways, if I'm writing it SB here, speed of train B is equal to distance traveled by train B over time taken by train B, which is 180 kilometers divided by 4 hours. 4 hours. So that equals how much? 4,416 and 220, 4,520. I think you now have the answer. Out of these two, this is the faster train. Do right here where SA is equal to speed of train A and SB is equal to speed of train B. Very easy problems. These problems won't come in your exam unless and until they love you so much that they don't want to give you any sort of trouble. Clear? Conversions we learned. We learned how to calculate speed and take decisions. Let's go to the next problem. Now slowly your problems will build up. Okay. Next problem talks about a car. And this car travels 30 kilometers at uniform speed. Uniform speed means there is no change in speed during the 30 kilometers. Okay. 30 kilometers at uniform speed, and the uniform speed is 40 kilometers per hour. Many people write HR. Don't write HR. The way to write is km stroke h. And then, so this is the first 30 kilometers. And after that, it travels the next 30 kilometers. The next 30 kilometers at uniform speed of 20 kilometers per hour. You are asked to find what is the average speed of the car, right? What is the average speed of the car, right? Anyone remembers what is the formula for average speed?
Total distance
Okay.
time.
Total distance travel. Yeah, participate, children. If you
By
remember
total time day.
By total time.
total distance, you can keep your mics unmuted. Total distance traveled over total time taken. Now here we will have an issue. The total distance traveled is all known to us. The total distance is 30 kilometers for the first stretch and 30 kilometers for the second stretch. We know that. The total time taken, we don't know. We don't know the total time taken. It's not given, right? So we can write this as T1 plus T2. And right here, T1 is equal to time taken for first 30 kilometers. And T2 is equal to time taken for second or the next 30 kilometers. Right? This will be the total time. You agree with me? Total time will be how much time you took for first 30 and second 30, right? So our problem boils down to 60 over T1 plus T2. Now our job is to get T1 plus T2. This will be in kilometer per hour. This is the average speed. Now you can write calculation of T1. So you know, time is always given as speed is equal to distance upon time. So time is equal to distance upon speed. How many of you disagree? Correct. Speed is equal to distance into time. No. Distance equal to speed into time. This is correct. So time is equal to distance upon speed. So T1 should be equal to how much? 30 kilometers divided by, look, divided by, what is the speed? The speed was 40. Divided by kilometer per hour means the unit will become R by kilometer. You should know how the units change, R by kilometer, because you are dividing. Okay, if you have not understood, then let me write one more step. It's divided by 40 kilometer per hour. So how can I write this as 30 kilometers divided by 40 into R over kilometer? Samajh mein aaya? Now strike out kilometer and strike out kilometer. That means your answer is coming in R. You're doing a right job. So don't get it into fractions straight away. You can write this as 3 by 4, or if you take it into fraction, how much will it be? 4. 0.7 is 28, and then 220, 4, 5, 20, 0.75 R. 0.75 R means how much? How many minutes? Can anybody tell me?
45.
Yes, very good. 45. 75% of an hour is actually 45 minutes. See, again, percentage is coming into play. 75% of an hour is 45 minutes. Okay. Can you calculate T2 now? Now we can calculate T2, calculation of T2. So T2 should be equal to 30 kilometers divided by, how much did it speed up to? Okay, it slowed down. It slowed down at 20 kilometers per hour. Sorry. So it becomes 30 kilometer divided by 20 into R over kilometer. Kilometer cancels kilometer, and you get 30 over 20, which is equal to 1.5 R. So total time. That's why I say, do not make it into fraction straight away, decimal straight away. Keep it in fraction. Total time is 3 upon 4 plus 3 upon 2. Okay. So 4 is the LCM, 3 plus 4 divided 2, 2, 3 is 6. That is 9 by 4 R. Problem doesn't stop here. We need to now calculate average speed. So average speed will be equal to 60 divided by T1 plus T2, which is 9 upon 4, right? This is kilometer and this is R. So that's 60 into 4 by 9, 339. And then how much is it? 326, 20, 24 is 80, 80 divided by 3, which is equal to 326, 220, 36, 18, and again 220. So 26.66, it will be recurring. So, okay, so since we are doing physics problem, it is 666 and it goes on. So you can write this as 26.67 kilometers per hour. Did you understand the 6-7 part? If the third digit is 5 or more than 5, you increment the digit before it by 1. So it becomes 26.67. Okay. How many of you had a problem in this one? Easy problem. Always make sure the units are correct, and whatever you are trying to calculate, whether the units are satisfying you or not. What I mean to say by that is, I was calculating time, so I should check these things, whether I'm getting my answer in H or not. That means, yes, my expression is correct, my equation is correct, and I'll be doing it in the right way. Okay? Got it? Okay. Next one is a more interesting problem. The next problem is a very interesting one. Okay, let's take this problem now. You have a 120 kilometer track. First, understand the problem. You have a 120 kilometer track. Okay, so let me draw the track first. Right. This is a 120 kilometer track. Okay, out of which it says that the train travels the first 30 kilometers. First 30 means how much portion of the track? 1/4 of the track. Do you agree or not? It is 120. So the first 30 kilometers, this is the first 30 kilometers. The train travels the first 30 kilometers. So at this section, the speed of the train is 30 kilometers per hour. श्रेयस पेन लो, हाथ छोड़ो, concentrate करो 1 घंटा, अभी छूट जाएगा ना, कुछ समझ में नहीं आएगा. If your mind is not concentrating, go stiff on your mind. I have to concentrate. मैं बार बार बोल रहा हूं, आप न्यूमेरिकल फिजिक्स के इतने आसान नहीं होते. पेन वेन मत छोड़ो, पेन लो and start questioning the problem. क्यों सर ये लिख रहा है, ऐसा क्यों हो रहा है? Do not give away. अभी दे दोगे ना, बाद में न्यूमेरिकल मैं obviously it's all becoming easy because I am doing the problem. What if when you start doing it? Please understand. I said that it is a 120 kilometer long track. So why did I mark 30 here? Because 30 is exactly 1/4. ये सब दिमाग में खुलना चाहिए अभी से. 30 is exactly 1/4. It travels the first 30 kilometers with a uniform speed of 30 kilometers per hour. Okay. Now they ask you, what is the balance stretch remaining? Okay. What is the balance stretch? This is 120 kilometers. So the question they are asking you is, this much is 30. Then what is this stretch?
90.
Very good. This much is 30 kilometer. So this much is 90 kilometer. Now they are asking you, what should be the speed? What should be the speed of the train? Okay, in this part of the 90 kilometer, this is the second, this is say stage 1 and this is stage 2. In stage 2, how much speed should the train maintain so as to average? Very, very interesting question. Overall journey, the train should average something as how much? It's asking to average 60 kilometers per hour for the entire trip. 60 kilometers per hour for the entire trip. Okay. The average speed. How many of you understood? The problem is like this. In half yearly, you scored 30. How much should you score in the second term so that throughout the year your score should be 60? It's asking you something like that. Did you get it? How to attack this problem? Again, same problem, same thing. They tell you, what is the average speed formula? Average speed is equal to total distance traveled by total time taken, right? The average speed value is already given to you. How much? You should maintain 60 kilometers per hour overall. Total distance traveled, I don't know. Do I know? Yes, I know, 120. What is the total time taken? Sir, I don't know what is the total time taken. So it will be T1 plus T2. Right? But they have asked you what should be the speed in the second part of the journey. T1 plus T2. In the second part of the journey, if you want to find out speed, what is the formula for speed? Speed is distance upon time. Time is T2. Do you know distance? Yes, sir, 90 kilometers. Do you know T2? No, sir, I don't know T2. So if you are able to find out T2, your job is done. Do you know T1? Sir, we can find T1 from here. This speed is, this is equal to again distance upon time. What is the distance? Sir, 30. What is the speed? Sorry. Okay, the speed is equal to distance upon time. So do I know this time is what? T1. Do I know T1? I know T1 because I know this speed. The speed is 30. How much should T1 be? 1 hour.
1 hour.
1 hour. Very easy. You are covering 30 kilometers at a speed of 30 kilometers per hour. What do you mean by 30 kilometers per hour? You mean that in 1 hour you are going 30 kilometers. So let's start solving this. Okay. So let's calculations. Let's do our calculations and let's do our first calculation for T1. So what should be T1 equal to? Distance is equal to speed into time. So time is equal to distance upon speed. What is the distance? Sir, 30 kilometers. How much was your speed? 30 kilometers per hour. That means it becomes 1 hour. T1 is 1 hour. We got our data. Right? Let's calculate for T2. We don't know what is T2. So let's calculate. Now we are going to calculate for T2. So how do we calculate for T2? We will use the top equation. The average speed of 60 is equal to 120 divided by T1. T1 is 1 plus T2. Calculations are much more easy. 0 cancels 0. 6, 1, 6 and 6, 2, 12, right? Learn these easy methods of calculation. Now multiply 1 plus T2 with 1. So it's 1 ones are 1. 1 into T2 is T2 is equal to 2. Or T2 is equal to 2 minus 1, which is equal to 1 hour. Okay? T2 is also equal to 1 hour. Time taken for second stretch is 1 hour. Now you can find out speed for second stretch. Speed for 90 kilometer stretch. What is speed equal to? Distance upon time. Distance by time T2. What is the distance? Sir, 90. What is the time? 1.
1 hour.
So you should maintain 90 kilometer per hour. समझ में आ रहा है? Now, according to me, we solved this problem in the utter foolish manner. Okay. Once you are done, I'll tell you how to solve this problem in a very clever manner. Although this way explains you the problem very nicely, but this was a foolish way of doing the problem. Right. Let's see. Let's see what foolish way what foolish thing we had to do. What we have done.
1 second. I'm just copying.
Yeah, sure. पहले इसको copy कर लो. I hope you have understood the problem. Average distance is equal to total distance traveled. Suppose this problem comes in an entrance exam and you have to tick the right option. You don't have the time to do all these things. You should start applying your head. Well, we'll see that. Written, copied, problem copied. Okay, what was the problem all about? There is a stretch which is 120 kilometers, out of which 30 kilometers the train went on a aram ka speed, whatever it did. It's just like cricket match, you have played slowly. How much should you speed up or slow down in your second part so that you maintain an average speed of 60? Did you get the problem? This was average speed. Forget about the entire workout. Look at me and let's start doing it. How much was the distance, children? Overall distance?
120.
120.
120.
What is the average speed you were asked to maintain throughout the journey?
60 kilometers.
60. Vanya, idhar ho gaya to dekho beta. Ye discussion suno. You were supposed to maintain how much? 60 kilometers. Do you agree? If you maintain 60 kilometers, in what time will you cover 120 kilometers distance?
2 hours.
2
2
hours.
hours. Okay, 2 hours. Out of 2 hours, the question itself tells you that the first 1 hour you have wasted. Right? How much time you have balance in your hand?
1 hour.
1 hour. How much distance you have to cover in that 1 hour?
90.
90
So
kilometers.
what should be your speed?
90 kilometers.
So did you understand how big fools we were to solve it in this manner? You get the pleasure part of it. The sense of Beokufi is also something you should enjoy. Did you understand? Overall, we have 60 kilometers is the speed we need to maintain. We are given a distance of 120. How much time will take? 2 hours. Out of 2 hours, our friend Jaideep Das has already wasted 1 hour. 30 kilometers in 30 kilometers speed. So he's left with only 1 more hour. 1 more hour is left with. How much distance he has to cover in that 1 hour? 90 kilometers. So what should be his speed? 90 kilometers per hour. ऐसा सोचने का प्रॉब्लम्स मिलने से ठीक है क्या वो आज सब लोग इतने दुखी क्यों सबको क्या डोज वोज मिला है क्या घर में नो वन इज स्माइलिंग थोड़ा सा सुधृति प्रतीची और नेहा आर स्माइलिंग अ बिट बाकी वानिया फुल सीरियस श्रेयस फुल सीरियस क्या हुआ श्रेयस कुछ हो गया क्या जमीन उजड़ गई खेत उजड़ गए फसल बर्बाद हो गए क्या हुआ श्रेयस what happened dear why are you like this today क्या धोखा हुआ क्या किसी को कुछ लव लेटर दिया गमला मार दिया क्या तुम्हारे मुंह पे ऐसा चढ़ा नहीं, मैं सोचा वो हुआ, सजनी ने फूल तो मारा पर गमले के साथ मारा, ठीक है ना। चलिए अगला सवाल. So this ends our problems, the type of problems that we usually get in a average speed type of problems. There is one more problem. I can leave that problem for you. That's the sample problem number 5. Aap koshish karna. Let's go to a little bit of theory today, and we will now cover velocity. Sample problem number 5. Okay, Sudriti, you had a question. Where did you post that question of yours? It was in
Sir, on WhatsApp to your private.
WhatsApp. Can you
I
post?
can, yes, sir, I can post it.
Just
I have to make the
post it right now.
diagram.
Can
Sir,
you
can you give me a minute? I have to make the diagram.
No, not diagram. Where is the printout of that? Where is that photo? It's in WhatsApp.
Huh.
1 minute. Wait. Let me forward it from WhatsApp here directly. Give me 1 minute. Okay. Otherwise, that will remain.
Sir,
Yes, sir.
sir, in sample problem 5, what is 0.52h?
Sample problem 5. 0.52 hours. 0.52 hours. What you are asking all this easy stuff? Okay. Give me a minute. Let me bring this problem here. CBSE grade 9. Okay, then let us come on our. Let me post that problem from here to here.
Sir, do you want me to send it again?
I have got it, madam. What you are all holding? Again, another problem.
Yes, sir.
Eh,
We have to calculate displacement and distance.
oh, such folder. Okay. 1 minute, kiddos. Okay. This is a problem that Sudriti has brought up. I hope everyone can see this problem. She has got. Okay, this is with velocity.
Yes,
Then
velocity.
let me cover up velocity and then let me do it. Okay.
Huh.
I'll hold this problem as of now. Let me cover up velocity and then we'll do. I thought it was with displacement. Okay, right. Chalo, children. So we conclude, give a bye-bye to speed forever. Speed will no more be discussed in our grade 9 after this. So we now move to what will be discussed a lot, which is velocity, for which our friend has been waiting for. Velocity. Okay, aaj velocity ho raha hai. Okay, velocity. The definition for velocity says, okay, recall the definition for speed. Speed was distance, the ratio of distance over time. So velocity is just like a cousin brother of speed, is the ratio of displacement over time. Okay, so we need to understand now displacement over time. So what do we get from displacement? There are two things. Okay, this we have already bid goodbye. Distance means, if you ever forget, remember distance means you can go the way you want. Displacement means you always go in straight lines. You always go in straight lines, right? That's the first thing you should understand. The second thing is, this gentleman is a vector quantity. If the parent is vector, the child is also vector. That means velocity as a quantity will have both magnitude as well as direction. So the ideal way to say velocity would be, and this is represented by V, V would be, if I say 5 km/h, I should also say east. Means this part is the magnitude and this part is the direction. Speed did not have this. Will you understand? Okay. Now let us see the different ways to interpret this word called displacement. Can I also say displacement is distance traveled in a straight line? You can't deny with me. If you are unable to understand, just look what I'm doing. This is point A, This is point B. Like this is point A and point B. How many different distances can be there between A and B? Common sense apply karo. How many distances can be there from A to B?
Infinite.
Infinite, because it all depends upon the way you think. Don't I fully agree with you? But there is one unique distance also. And don't you think out of those in who said infinite, out of those infinite, there is one distance which is a straight line distance also. It is also there. This is also one of the part. And I can call this fellow with a special name. It's like I'm a little bit more biased towards it. Is it not displacement? Shortest straight line distance between 2 points. Right? Got it? Now, try and understand what I'm going to say now. To cover this shortest straight line distance, you might require a time. Let's say that time is T1. Let's say T1. There can be another way to go till B. Sir, I would love to go till B in this manner. Okay, please go. For that, there would be a time T2. Agreed. Sir, I would like to go to B in this manner. For this, there might be a time T3. That means, in order to reach from A to B, we can have speeds. What all type of speed we can have? We can have speeds can also be infinite. As many type of distances you have, as many type of speed. Let's call them, the speeds are S1, S2, S3, to say Sn. So many different speeds we can have. But out of all these speeds, there is one cute speed S1. There is a cute speed S1. And this S1, I would say, is S1 is equal to shortest straight line distance by the time taken T1. Are you understanding? Of all the speeds, there is one speed which is the speed you maintain in order to travel the shortest distance. That means velocity as a quantity can also be said as, what is velocity? It's a special speed. Speed in a defined direction. Or to be more particular, that defined direction is a straight line direction. Isn't it? Let's think. How many of you are able to understand this? What is velocity? Velocity is displacement over time. What is displacement? Shortest straight line distance. Now I ask myself, to travel from one place to another place, what all are the various distances that are possible? One of the child said that there are infinite distances. So madam, if there are infinite distances, there are infinite speeds also possible. Don't you agree? But out of all those infinite distance, there is one cute distance which just travels straight. And for that also, there will be some time taken. So that speed is known as velocity. Samajh mein aaya? So every velocity can be a speed in a defined direction, but every speed cannot be velocity. Every speed cannot be velocity. Speed is like a class of student. Velocity is one perfect boy or one perfect girl. And the criteria is set. When does speed become velocity? Speed becomes velocity when the speed is in a defined direction. What direction? Shortest straight line direction. Travel to the shortest straight line direction. The time that you take, record that, divide that distance by the time. The value that you get is the magnitude of speed. Right? And that will always have a direction. What do I mean by that? Zara bhi aur dekho. I'm taking time so that you understand the concepts. Okay. There are 2 points. Now, we are now fine with one thing, that the shortest straight line distance. Okay. Let's take the shortest straight line distance. So the shortest straight line distance is this. Very good. Sir, the value, since this is the shortest straight line distance, I can say that this is a displacement. Yes, sir. This is a displacement. Call it S. Yes, sir. I've called it S. And the time you took, time taken was say T. Very good, sir. This is from point A to point B. So you define velocity as S by T. No issues? No issues. Let's say this S was 20 meters and this T was say 4 seconds. It's just an assumption. It's just an assumption. Then what is the value of velocity? Okay, 5 meters per second. Everyone agrees with me? But what you're forgetting is that this fellow is a vector. And if it is a vector, it is supposed to have 2 feathers on its head or on its crown. One is the magnitude. You have found the magnitude. What about direction? Now, why direction is important? Let's understand that. Why direction is important? Don't you think that from A, I could have also gone straight line like this? In this case also, the distance is 20 meters. Don't you agree? Yes, this is also 20 meters. How much time I would have taken? Sir, you would have taken 4 seconds. Sir, not only that, in fact, if you would have moved in this whole circle, anywhere you would have gone would have been 20 meters, 20 meters, 20 meters, 20 meters. Don't you agree? It's a radius. But is that the velocity? No, sir. Because if I took arrow number 2, I am not reaching B. I am reaching somewhere else. That means to reach B, there has to be a specific direction. A specific direction. Otherwise, I am not reaching B. That's why the direction part comes in velocity. When you go on a straight line, from my tower to Neha's tower, B to A, it's a straight line distance of so and so. But in the same straight line from my tower, I could have gone to E tower also. I could have gone to D tower also. I don't reach Neha's tower. So I won't be able to get velocity. So please specify. So how do you say, Mr. Das, travel 20 meters, 30 degrees north from your tower, and you'll take some time of around 4 seconds, and wherever you stop is Neha's tower. So what do I say? Mr. Das, travel 5 meters per second at a direction of 23 degrees north. That direction is very important. Imagine that first day example that we gave. A crow was sent to Glendale school, and the crow was saying, I will fly this much, but fly in a specific direction. Velocity needs direction. So velocity, what all did we understand so far? Let us make a small recap on velocity. A small recap. Velocity is denoted, velocity is denoted by the small v letter, and it is expressed as S over T, where S stands for displacement. Mind you, displacement. T stands for time. If we go by SI units, then the unit for velocity should be in meter per second. So we will say that the velocity of Shaurya is said to be 1 meter per second if Shaurya can travel in a straight line and cover a displacement or a distance. You can use the word distance because you have specified Shaurya is traveling in a straight line. In a straight line, distance and displacement are same. If Shaurya can travel in a straight line and he is able to cover a distance of 1 meter in 1 second, then we say that the velocity of Shaurya is 1 meter per second in the direction of his travel. Be very clear what all you have to say, because you are defining a vector quantity, right? So whenever you quantify velocity and you say S by T, somebody may say, sir, I would like to say it as S by T, but I will refer S not as displacement, but as distance. Then you need to add 2 more words. Distance in a straight line. Straight line. That distance cannot be like this. The distance has to be straight line. Has to be straight. Then only it is displacement over time. SI unit is meter per second. Okay. The next, this was the first point we studied. The next point we studied was this is a vector quantity because one of its parent is vector, that is displacement. That means velocity will have both magnitude and direction. Sir, can you give an example? Well, why not? For example, V is equal to 4 meters per second north. Right? Okay. Now, an interesting thing. In many problems you will encounter V is equal to -5 meter per second. Can anyone tell me what does -5 mean? Many children in job level also are unable to answer this question.
So it means that it's moving the opposite direction.
Very good. Many are people say what you know, -5 means speed velocity is reducing. Vectors, I told you first day. Vectors, the sign only tells us about direction. Means it is like this. If this is a person, and since Sanvi told the answer, I'll give the credit to her. Let's say this is Sanvi. If Sanvi thinks that traveling to the right, by her notion, traveling to the right is the positive direction, then she will say that I was traveling with a velocity of 5 meters per second, whereas my younger sister actually was traveling on the opposite side. So her and the speed was same, and the speed was same. Look at what I'm saying. And the speed was same. I'm not saying the velocity was same, because if the velocity was same, the younger sister also should have gone this direction, but she did not go this direction. Therefore, what is same? The speed part is same. Only the magnitude part is same. So her younger sister goes this way with the same speed. So she is traveling at a velocity of -5 meters per second. Again, velocity has got two parts. Let's see this. This was Sanvi. So her magnitude was 5 kilometers per hour. This is Sanvi's sister. Okay, what is her magnitude? Again, 5 kilometers per hour. Now let's talk about the direction. Let's talk about the direction. The direction was Sanvi traveled east, but her sister traveled west. That's why if I combine these two, I will say her sister traveled with 5 kilometers per hour and she traveled with +5 kilometers per hour. Vectors. 5 Newton, look at me, 5 Newton, -5 Newton. Pain will be same because the slap is hit with 5 Newton. Cheek will be different, hand will be different. Okay. Vivan, your palm lines are very good. You have got very good line of heart, line of head, everything. Yes, good. Yeah, tell me some questions.
Sir,
ये बहुत डेटा बता रहा हूं, हाँ, इसको इतना आसान से छोड़ मत दीजिए, बहुत कुछ यहाँ समझना है. खाली डोंट जस्ट से वेलोसिटी इज डिस्प्लेसमेंट बाय टाइम. बहुत एंगल से सोच सकते हैं. वेलोसिटी इज डिस्टेंस इन अ गिवन डायरेक्शन बाय टाइम. वेलोसिटी इज speed in a given direction by time. Velocity is speed plus magnitude. Velocity is speed plus direction, not magnitude. Speed plus direction. Yeah, sorry, Shreyas, your question, please.
Sir, in the example which you have given us, Sanvi is traveling with speed 5 meters per second to east, and her sister is traveling.
Sorry, 1 minute. Before that, let me just correct it. I made it 5 kilometers, my bad. So 1 minute kilos. Okay, can't help it. They are all kilometers. Let me just circle this once again. Yo, go ahead.
Yes, sir. So, sir, what will be the velocity if a sister is traveling -5 meters per second and she's traveling +5 meters per second?
Sister is traveling -5 meters per second.
Yes.
Yes. So when you talk about velocity, there are two parts to it: magnitude and direction. So magnitude of our sister is 5 meters per second. Don't bring the minus there.
Okay.
Don't bring the. See, the thing is, both of them are exactly traveling away from each other, but at the same pace.
Okay.
So her sister, if you say, what is the velocity of Sanvi? 5 kilometers per hour. Sir, can you be specific? 5 kilometers per hour east. Sir, what did you reply in the first option? I was actually talking about speed because I didn't give the direction. What is the velocity of our sister? 5 kilometers per hour. No, sir, be specific. Negative 5 kilometers per hour. Okay, the two sisters are walking apart from each other. The two sisters are walking apart. Now, let me give another example. Sanvi is traveling at 5 kilometers per hour and east, and her sister is traveling at 3 kilometers per hour east. That means Sanvi is ahead of her sister. Sanvi is ahead of her sister because Sanvi is going at 5 kilometers per hour east. जोर से जा रही है. Sister is trying, hey, wait, where are you going? Sister is also going in the same direction. Let's see another way. Sanvi is traveling at minus 5 kilometers per hour. Means Sanvi is going west. Sister is traveling minus 2 kilometers per hour. Means sister is trailing. But if the sister was going at minus 7 kilometers per hour, Sanvi is trailing. Sister is ahead of her. And both are traveling towards the west direction. Got it? Negative velocity and positive velocity. So can you give me an example, a daily life? Let's put Shaurya on the driver's seat of the car and let us make him travel from my tower to, say, main gate, and let him go straight. After he goes straight, he again engages the brake and then goes with reverse gear and he comes back. What was his velocity? Positive velocity. Again, negative velocity because he's traveled back. That does not mean his speed is reducing. That means he is actually traveling in opposite direction. Can we show that a bit? Let's try and see that in a graph. Then only graphs become interesting. Look at the graph. I'm trying to plot a VT graph now. Velocity with time. Try and understand. Velocity with time. As time goes, and let's say it's a constant velocity. Okay, as time goes, my student Shaurya travels from his tower to the main gate with a constant velocity. Say he took something around 1 second, and this was say 7 seconds. He took some 6 seconds to travel from where? To travel from his house, say his flat, to main gate. Understood? Constant speed. Battery driven vehicle, constant speed. And there Shaurya decides, oh, I forgot my wallet, but there is no space to again take a turn. So what happens? He will first stop here. He will stop here, right? After he stops here, there will be some time where his velocity is 0. Please watch. Can he immediately come back? Is it possible that immediately he comes back in this direction? Socho. He went this way and he has come back exactly in the straight line. Is this possible? In graph, real life? Why not possible? Why not possible?
Because he'll take some point for let the car to also stop.
Yes, very good. He takes some point for the car to stop. He has to engage the reverse gear and then he has to travel. So some time will pass. And during that time, what will be his velocity?
0.
0. So from 7 to 8 seconds, what is Shaurya's velocity? Or 8 or let's say 9 seconds. He has taken, or let's give him, he's a slow fellow. Let's say he took 3 seconds to actually, engage the gear, reverse gear, and now he's ready to fall back. So how should the graph look like now? After 10 seconds, Shaurya starts coming back. Kya ho gaya? Answer kar sakta na? After 10 seconds, he starts coming back. And say with a lesser speed, because he is now with a lesser velocity, because he is now reversing. He's a little bit afraid. So he comes back in this manner. Please don't understand these as positions. Huh? This cannot be position. This is just the speed data. This is how he's coming. This is the real life scenario. We don't have any information what happened from here to here. So let's see his process flow. This was point 1. From point 1 he started. This was point 2. When he braked, And till 0.2 to 0.3, there is no data. There's no data. Zero. Velocity is zero at that time. 0.1 to 0.3. There's no data. There's no graph. And again, 3 to 4, he has come back. Are you able to understand? This part will be a negative velocity. And this part will be a positive velocity because he's just traveled ulta. Does not mean his velocity is less. It's the same velocity, but in a different direction. So rather, how should I use my words? It's the same speed, but in a different direction. Able to understand now? A bus travels from Delhi and goes to Jaipur. Let's say Delhi to Jaipur is a straight road. If we say that the speed of the bus, mind my words, speed of the bus was 100 kilometers per hour, how will you say the velocity? Sir, Delhi to Jaipur. So your drawing itself is wrong. Why? This is not the way. Ulta karo, sir. Jaipur is west of Delhi. See, drawing itself was wrong. This is Delhi, this is Jaipur. So how did the bus go? Sir, morning trip, it went this side. It's going west. So by convention, we'll say that during the morning journey, its speed was velocity was minus 100 kilometers per hour. Evening, the bus again returns back from Jaipur to Delhi. Okay, it's come this side. What is this velocity? Now this is V1.
Sir,
Will be plus 100 kilometers per hour. Yes.
sir, why won't it be plus 100 kilometers per hour?
Where? During the daytime.
Yeah,
Morning.
during the daytime.
Because we're
That's
coming
by
back to east.
convention. You take convention. Jaipur is west of Delhi, na?
Hmm.
Jaipur is Rajasthan, re Baba. This is a
I
convention.
think the west.
You could have taken positive. If you take that as positive, the return should be negative. But that is a little bit more complicated that you are trying to do. Did you understand? Because Jaipur is on the west and Delhi is on the east of Jaipur. This is not this south. So if you go by India's map, this is Delhi and here is Jaipur. So you travel this way. Isliye negatively. We
Will
go
they
with
ask-
the Cartesian coordinate system. But see, Shreyas, if you argue with me and you say, no, sir, I will take that as minus 100, I cannot fully dispute with you, provided you are taking the return journey as, sorry, you're taking plus 100, you take the return journey as minus 100. Then I can't dispute with you. Whatever you write, you should give a note, assuming the travel from Delhi to Jaipur to be in the reverse direction. You write like that. फिर negative डाल दो, कोई नहीं काटेगा आपको.
Will they ask questions like this, like Delhi to Jaipur or Jaipur to?
You are asking that with the geography part.
Yeah.
No. Don't be afraid. No one will ask you that question.
ठीक है,
Why,
फिर ठीक है.
why are you so afraid of cities and their location? Okay, nobody will ask.
फिर याद नहीं है मेरे को सारी cities इसलिए.
Okay. So is the concept of velocity clear? And if the concept of velocity is clear, let's now come down to some notations. And from now on, you will follow notations. And the notations are velocity is denoted by V, time by T, and displacement by S. So the formula says V is equal to S by T. ठीक है? Okay. Next two topics and I'll leave. Uniform velocity. Do you remember uniform motion? A body is said to be in uniform motion if it travels equal distances in equal intervals of time, no matter how small the time intervals are. Now we are defining uniform velocity. Look, you will be able to define from motion itself. A body is said to be in uniform velocity if it travels equal distances, equal displacements. Because velocity's daddy is
Given
displacement.
direction.
Velocity's daddy is displacement, right? In equal intervals of time, no matter how small the time intervals may be. But say Sudriti does not agree with me and she wants to use the word distance, then I have to little bit moderate my definition. A body is said to move with uniform velocity. She wants to use the word distance. Okay, now see how I'm changing my definition. A body is said to move with uniform velocity if it travels in a straight line. पहले ही मैं बोल दिया, if it travels in a straight line and covers equal distances. Each of the equal distances will be displacement now because you are traveling in a straight line. देखो समझने की कोशिश करो. First I said a body. Look at my definition. Don't write. A body is said to travel or said to move with uniform velocity. Okay. Now, up till here will be a common. Option 1, the way I was defining was if it covers equal displacements, okay, in equal intervals of time, hold on, of time, no matter how small the intervals may be. Right. Our friend Sudriti has a dispute with this word. And she says, no, sir, I don't agree with you. I want to use the word distance only. She says she wants to use the word. This is her definition. She says that she wants to use the word distance. But there is no, but I need to tell her, look, Sudriti, it's not same. Displacement and distance is not same. Here my displacements were like this. My displacements were like this. And you are saying equal distance, equal distance, equal distance, equal distance, equal distance. They are not same. So sir, same karo na. So kaise same karo? So then I say, then your definition needs little bit of moderation. So this is Sudriti's definition. A body, so I'm now trying to moderate her definition. A body is said to travel with uniform velocity if it travels in a straight line. ये डाल दिया. अब जब straight line में गाड़ी travel करेगा, देखो बच्चा, अब जब गाड़ी straight line में travel करेगा, you try and knock off some equal displacements. Every equal displacement will be a straight line, straight line, straight line, straight line, straight line, straight line. You cannot get this curve. So all these nonsense won't come in our picture. Now both the definitions are correct. Argue your definition. So one way she was said that, sir, a body is said to move with uniform velocity if it covers equal displacement in equal intervals of time. Fine. Sir, if I change the word to distance, what should I do? Then first make the body move in straight line. A distance in a straight line is a displacement only. समझ में आ रहा है कि नहीं? बड़े face बना रहे हो आप लोग. Overhead. Is it too much? Then I'll stop. We have got enough time whole year to study. But I don't want you to study with boredom. आपको अगर कभी भी लगता है सर ज्यादा हो गया है आज रोक लीजिए, रोक लेंगे, कोई प्रॉब्लम नहीं है. पर आप जितना देर पढ़ो इंटरेस्ट के साथ पढ़ो, नहीं तो आप प्रॉब्लम सॉल्व नहीं कर पाएंगे, फिर रख के जाना पड़ेगा. How many of you understood the difference between these two definitions and the way it was written? Okay, both the definitions are correct. But had Sudriti not included the yellow portion, then Sudriti's definition is not correct. Then her definition would be wrong. So if she is defining it with uniform, then we should say a body is said to move with uniform velocity if it moves in a straight line. Many books will say specified direction. Specified direction is always a straight line only. Specified direction means go there, shoot an arrow. Arrow will always travel straight. Specified direction is a straight line motion.
Sir,
Holy sir.
can it also be a body is a body set to travel with uniform velocity if it covers equal distance in a given direction in equal intervals of time?
Yes, equal direction distances in given direction. Specified direction you should use. Specified direction माने straight line ना. देखो अच्छा क्या हो गया, जैसे ही आप बोल दिया specified direction means this is a specified direction, right? अभी इसमें equal distances सब कैसा होगा? Displacement नहीं होगा क्या?
होगा.
These are all displacement. But if you don't use the word specified direction, then I can actually go like this. Now let me see the displacement. अब जरा displacements देखो तो. अब ये displacement 13, 18, ऐसा, ऐसा, ये displacement थोड़ी हुआ. ये सब तो distance हो गया अभी. Because they're not straight. So that specified direction and straight line is very important. वो अगर इसलिए ये सब रखने का ही नहीं, ऊपर वाला बोल दो ना, equal displacement in equal intervals of time, काम खत्म. है ना? एक बार में ही दोनों मर गया आपका. You say straight away that it is equal displacement. Sanvi understood? Neha, Zoe, अमूल्य बेटा समझ में आएगी नहीं? ठीक है? बहुत चीजें बारीकियों को यहाँ नजर देनी पड़ेगी आपको. बारीकियों पे नजर डालिए, लाइक अमिताभ बच्चन. बारीकियां बहुत इंपॉर्टेंट है फिजिक्स में. ठीक है? और नॉन यूनिफॉर्म वेलोसिटी मतलब a body is said to travel with non-uniform velocity if it covers unequal displacements in equal intervals of time. Non-uniform velocity का मतलब ये नहीं कि distance हो जाएगा, वहां भी displacement है, but those displacements are not uniform. Do you understand? Non-uniform velocity means non-uniform velocity does not mean that you are covering distances. You are still covering displacement. What is not you? Shall I show you with one diagram and then we can leave? Right. This is specified direction. Let me show you non-uniform velocity. You know what is non-uniform velocity? कभी इतना cover कर लिया, कभी इतना ज़्यादा, कभी छोटू. These are all straight lines. These are all displacements, but unequal displacements in equal intervals of time. So tell me, in our daily life, do you encounter velocity or speed? Last question.
Speed.
You can't go with velocity, otherwise you'll bang yourself on that pond. Specified direction you can't. A missile goes with velocity. A billiards ball goes with velocity. A javelin to some extent goes with velocity. After that, gravity acts and the javelin starts falling down.
What about an airplane?
What about?
An airplane.
Aeroplane is all distance, not displacement.
Could be, no displacement.
For some stretch of the journey.
Ah, yeah.
Maybe the takeoff is a displacement.
Mhm.
After that, when it maneuvers, it's not more a displacement. Once you are away from your straight line, you have immediately gone into distance.
Distance.
Bolo sir.
Can writing also be displacement? No, velocity.
कहाँ कैसे डिस्प्लेसमेंट? राइटिंग में तुम ये लिखते हो ऊपर. अभी जैसे तुम राइटिंग लिख रहे हो, प्रेम पत्र लिखोगे अपने गर्लफ्रेंड को, देखो डियरेस्ट, ये हो गया ना, ये सब डिस्टेंस है. डियरेस्ट ये डिस्प्लेसमेंट है.
No, you're writing the words in a straight line. The
नहीं,
lines.
but the words are all being like this ना. उसमें तो हमारे जमाने में क्लास में जैसे हम लोग लिखते थे ना, ऐसे लव लेटर मार के क्या से करे, ऐसे मार के ऐसे एरो मार देते थे. ये डिस्प्लेसमेंट है, ये वाला डिस्टेंस है. जिंदगी भर याद रहेगा अभी तुमको. हाँ, एग्जाम्पल देते हैं सर, सब उल्टा सीधा चीज पढ़ाते हैं. मम्मी नहीं पढ़ना है हिसाब में, कुछ गड़बड़ कर, तो याद रहेगा ना कम से. ठीक है. So uniform velocity, non-uniform velocity, we have understood. थोड़ा सा चीज रह जाएगा, and then we will do some problems and get on to acceleration. We are going slow so that once our concepts are clear, every numerical you will be able to do, and you will not only do from Lakshmi Singh, I'll make you do problems from H.C. Verma also. और आप करोगे. H.C. Verma is head of the department physics IIT Kanpur, और आप उसके problems सब आप ही करोगे. देखते रहना, टकार 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 होते रहेगा. पहले concept clear करो. A concept clear नहीं है, then नहीं होगा. If you are a good cook, if you are a good chef, the utensils don't matter, the kitchen doesn't matter, the type of fire that you get doesn't matter. You're a good cook, you know how to cook it. You'll be able to do. ठीक है? So रंगारंग कार्यक्रम खत्म करते हैं. Your question will take in the next class, Sudriti, because that has velocity and time. So once we do this, we'll do some problems. So please study up till velocity. And one point that I did not get the time to cover was, if you want to change velocity, you can change it in two ways, because velocity is a vector. Even if you change the direction, velocity changes. Just one word of Shaurya. Just one example of Shaurya's, and that will kill the discussion for the day. Shaurya says aircraft. Okay, Shaurya, you and me are on Sukhoi Mark 1. We are going this way. Displacement. Velocity. Velocity. And then they suddenly say, Roger, I am getting in. Direction change. Speed was same, but velocity is different. Did you understand what I tried to say? If this is velocity v1, this is velocity v2.
Velocity V2, yeah.
Here he is maintaining something like, say, 300 meters per second. Here also he is maintaining 300 meters per second. Then, sir, why are you saying that the velocity is different? I am saying the velocity is different because the pilot has changed his direction. And in grade 11, you will get this problem that a Boeing then maneuvers 30 degrees away from his direction. Velocity has changed. Velocity has changed. The speed is same. The aircraft speed is same, but the velocity has changed. Okay?
Yeah.
And if Shaurya was going like this, he's our fighter pilot. Okay, sorry. He's our fighter pilot. Just see this. Let's see this one. Shaurya is traveling like this. Okay. And from here, Shaurya travels like this. Okay, let's say this is 300 meters per second. Roger, slow down. 200 meters per second. Velocity has changed. Direction, sir, no, he is still heading towards the enemy territory only. His direction is same. But vector na, किसी एक को छेड़ोगे तो छिड़ गया, magnitude छिड़ गया इस बार. इसमें क्या हुआ? इसमें mag छिड़ गया है. Here, I want to throw away this pen sometimes. Yeah, this magnitude here, the magnitude has changed. And what changed here? Direction changed here. In both the cases, we will say this is velocity v1, this is v2, and v1 is not equal to v2, v1 is not equal to v2. And one more last example. क्या करूं यार, physics पढ़ाने से मेरा मन बैठ जाता है. Shaurya is going this way, and to give him cover fire, Shreyas is also going this way. Two different aircrafts. ठीक है, देखो क्या बढ़िया question है. This one is traveling at 300 meters per second, 28 degrees east. And he is also going at 300 meters per second, 28 degrees east. दोनों aircraft अलग है. If this is V1, this is also V1. This is the beauty of vector. Both the velocities are same because both mag is same, direction is same. And at that time, there is a kebab mein haddi. Kebab mein haddi means, you know, our enemy aircraft V1 is coming, dogfight. And he is coming like this. 300 meters, and let's put his data now. His data is 300 meters per second, 28 degrees west. We will call him as negative V1. He is just ulta to us. अभी समझ में आया? Clear हुआ? That does not mean V1 is slow. That does not mean Shaurya is fast. But how will Shaurya feel? Shaurya will feel that V1 goes past his nose with a speed of 600 meters per second. That is another interesting thing. That is the concept of relative velocity. वो और आगे बढ़ेंगे. Shaurya किस साइड जा रहा है? 300 इस साइड जा रहा है ना? V1 300 इस साइड जा रहा है.
So 300 plus 300, 600.
300. If you keep Shaurya constant, he will feel V1 flew at 600 meters per second, which means another 10 seconds more. If Sudhriti is going on ORR to airport, okay? Say if Sudhriti is going on ORR to airport straight and Sudhriti is traveling at 120 kilometers per hour and Neha joins on the lane beside Sudhriti and she is also going at exactly 120 kilometers per hour. See how interesting it is. This is Sudhriti. She forgot to put, you know, mascara. Neha can actually put mascara on her eyes. Because Neha will feel Sudhriti is stationary. Both are at the same speed, na? ये physics की beauty है. The relative speed between them is 0. एक दूसरे को खाना खिला सकती है. अभी सोचो सलमान खान एक ट्रेन से एक ट्रेन जंप मारता है, दोनों ट्रेन सेम जाएगा तो you can just jump from one train to another. And the beauty part of it is, if our friend Shreyas, okay, let's put the beauty part of it and close for the day. Don't mind. If Shreyas is traveling same way, Shreyas बोला सर वो लोग तो एक दूसरे को मस्कारा लगाते हैं. Shreyas 120 किलोमीटर में इस साइड जा रहा है, ठीक है? And Jaideep Das is going 120 kilometers on this side. Now this will be the fun part and we'll close the day. 120 kilometers per hour on this side. And Jaideep puts out his hand on his cheek. He will get a slap of 240 kilometers per hour. पड़ास से लगेगा उसको एकदम. Did you understand? Because we are traveling opposite. That's why when you are cycling or you're in a two-wheeler, if a small fly comes and hits your eye, you get a lot of pain. समझ में आया? क्रिकेट का बॉल लगने से बहुत जोर से क्यों लगता है? उल्टा आ रहा है ना आपकी तरफ में. ठीक है, चलो आज यहाँ पे क्लास खत्म करेंगे, अगले क्लास में यहाँ से फिर जाएंगे. तो कोई मस्करा भी लगा सकता है, कोई चारा भी खा सकता है.
Sir,
बोलो सर.
so sir, if the cricket ball is coming at a speed of 10 kilometers per hour,
Ah.
and we're running towards the cricket ball at the speed of 10 kilometers
Impact,
per
the
hour.
velocity of the ball
20 kilometers per hour.
किलोमीटर पर
20
आवर.
kilo, okay.
हाँ, इसीलिए जब रायट में हमारी मांगे पूरी करो ऐसे दौड़ता है, पुलिस भी पानी उतना ही प्रेशर से मारता है. रेन डांस का फील नहीं होगा, उतना ही चोट लगेगा तुमको. ठीक है, बट इफ यू आर रनिंग अवे एंड द पुलिस इज स्प्रेइंग वाटर ऑन यू,
कुछ नहीं होगा.
तब मजा आएगा उससे. ठीक है, चलो गुड. सो फिजिक्स अगर आप मैकेनिक्स पढ़ना चाहते हैं, बहुत कुछ है अच्छे से पढ़ने के लिए, बहुत एग्जांपल्स हैं. चलते हैं, अगले क्लास में फिर मिलेंगे. ओके, रीड टिल वेलोसिटी, यूनिफॉर्म वेलोसिटी एंड दिस, एंड कम प्रिपेयर्ड फॉर योर नेक्स्ट क्लास.